Hello everyone, and thanks for attending. So this speech will be about containers and Dockers and how we think that benefits to OTT TV specifically. I'm Jerome, and I'm speaking for KeyPixel, now part of Anivia. So the scope will be this. Containerization and Docker are recent buzzwords in the OTT TV industry, at least. The question is why? So why is everyone talking about this, and why specifically Docker? And shall we care? The answer is yes. We think there is a special fit between Docker and OTT TV. So this talk is not a training on Docker. This is not a technical talk. This is about this relationship we think there exists between Docker and OTT TV. Some references I have used to build this, so you will be able to read this in the slides after the speech. First, I will start with a short intro on what is containerization, for those who don't know already, and Docker, specifically, why is it getting so much traction? Also, is it better than virtual machines? What are the benefits? There are benefits to the users and also benefits for the software developers themselves, and that is an important one. And where is it already used? So then we explore that relationship between Docker and OTT TV and why we think this is a perfect fit, actually. Then there will be a short talk about some technical aspects, both from a vendor perspective and from a user perspective, and also a word about microservices and what that's new paradigm. So intro on containers, then the relationship with OTT TV, and a short technical slide. So this will be the crux of the speech. This is the important part. This is why we think there is a fit between containers and OTT TV. Okay? I will start with the introduction on containers and Docker. So containers are a way to isolate the software from the hardware. And if you have been interested into containers, you've seen that diagram many times already. That compares two architectures to isolate software from hardware. The one on the left side is virtual machines, and the one on the right side is containers. So virtual machines rely on a host operating system running on a server, a hypervisor to isolate the server from guest operating systems. So each virtual machine runs in its own operating system. An app is an application that is the software function we are trying to implement. On containers, you have one less layer, actually. This is the container engine, which isolates the software from the hardware. So that is the main difference between virtual machines that we already know and containers. This is that additional layer that we have in virtual machines and that we don't have in containers. How do they compare? So based on this, you see that on virtual machines you need a hypervisor and running, and each application needs a full operating system. So the system, as a consequence, the system has a bigger, larger footprint in size, RAM, storage space, and also it's a heavier system. In containers, this is lightweight. It has a smaller footprint, and also it starts faster. So this is that point number 5 is important. That is, with a virtual machine, you have a startup time of about that you count in minutes, whereas with containers, you count in seconds. And point number 6 is about performance. In virtual machines, performance is degraded by about 20%. Whereas in containers, there is no performance overhead. So this is better for performance. So those 3 points are the 3 points that to us are important an important benefit of containers as compared to virtual machines. So back to this diagram, we've seen that containers are based on a container engine. So what is Docker? Actually, Docker is just one container engine, among others. This is a popular one. It's based on a former, it's based on another containerization technology, which is called LXC. And it benefits for a massive ecosystem, so that's why it's so popular. So that slide shows Docker ecosystem today. You can see this is an extremely rich ecosystem, and that's why Docker is a container engine of choice for containerization. We can name other container benefits. So containers help deliver a more reliable software. So why is that? Actually, because it simplifies the software developers' lives. And that is important because everything you do to facilitate the developers' lives will lead to a better software product. So in which way, in which way precisely? Well, first, there is portability. That is, once you design a Docker image, you can run that in any Docker engine. This is portable, provided you have the same binary architecture. Also, module-based testing is made easier because you can switch containers and you can assemble them. And the third one is also important. You can be assured that when you develop and you test and you qualify your system in a container engine, it will be in the exact same configuration as when you put your system into production, because it will also run in a container, on a container engine. So staging and production software will run in the same conditions as in your test lab. And the last one is that it facilitates agility and DevOps. So that's why we think containers bring a better software overall. Where are they already used? So containers are not new. They are only new to us in the OTT TV industry. Google, for instance, massively uses them for its popular services, Gmail, Search, YouTube. They say each week they start 2 billion containers. And also they create tools for containers which accelerates adoption in the industry. Containers are also used for running apps on mobile phones today. Containers are available even on Windows Desktop 10 and Server 2016. And Windows apps for desktop actually can be run into containers. And to finish with, all public clouds offer to run applications into container infrastructure. So that exists in Azure, in Amazon, so there are special product names like AKS in Azure, ECS in Amazon, Google Container Engine, Huawei as a cloud for containers as well. So you see this is already a widespread ecosystem. So after this intro on containers, why do we think this is so special for OTT TV? So I have to start with a foreword, an introduction, about what we call a software encoder. So I will focus specifically on the video encoder in OTT TV. So the question is this. At the end of the day, every software runs on a hardware. So how do we define what a software encoder is? How can you say this is a hardware encoder and this is a software encoder? Just because it has more wires? No, this is not the right definition. So probably the right definition is that with a hardware is based actually on the supply chain. On a hardware encoder, the same vendor provides the hardware and the function. So you cannot separate the video encoding function from the video encoding hardware. So that makes it a hardware encoder. In a software, so-called software encoder, you can separate them. So you can buy the hardware from A and the software from B. That's what we call a software encoder. So based on this, what does an OTT TV system look like in software? So this is a standard diagram for an OTT TV workflow. On the left side, we have a live workflow from the live TV streams. We will encode them, so there is a processing task that encodes them to multi-bit rate, for instance. Then they are packaged, so this is to create the HLS or Dash or CMAF assets. And then they are delivered to subscribers via a CDN. Also, those encoded streams, they can be sent to a cloud DVR for catch-up TV. On the right side, there is a VOD workflow, a file-based workflow. So from the VOD catalog, you will feed a VOD encoder that will feed a storage, a VOD storage, and that storage, whether from the VOD workflow or from the live catch-up workflow, will feed a just-in-time packager that will deliver the package asset to the CDN, to the subscribers via the CDN. So that is a quite standard workflow for OTT TV. So here it is. Why we think this is the good fit? Well, first, containers allow to compose the different software functions together to build a complete app. So we can compose software services to build that OTT TV headend. This is point one. Point two, in containers, we can also run several versions side by side. We can change that live encoder V1 with a live encoder V2 and not disrupt the entire system. We can just upgrade separate modules. We can even have several versions sitting side by side. So actually, we could switch that one to V2 and switch that one to V2 and V3, but keep V1 as well, and run several versions simultaneously. So that is allowed by container technology. The third point is that we can benefit from elasticity. So when, for instance, you add temporary live events, you can grow the number of live encoders, live packagers, and CDN modules for those new live services. And whenever the VOD assets grow or they need to be updated, for instance, when you need to update your VOD catalog, you can also grow temporarily the VOD encoders, the storage, and the just-in-time packagers whenever you have more viewers. So you can adapt to changing needs, actually. You can grow and reduce the system dynamically. This is elasticity. And the fourth and last one also derives directly from the container technology. Containers allow us to break the link between the software and the hardware and to keep performance to a maximum. So that is different from virtual machines. With virtual machines, you have a performance impact, whereas with containers, you don't. You keep performance at maximum, and performance is especially important in video, especially in video encoding, so that's why it is so important to keep that, to keep the performance at maximum. So, for instance, on that standard server bay, you could instantiate those different blue functions as different blue boxes with live encoders, live packagers, CDVR, just-in-time packagers, and also mix that with other functions, third-party functions you don't even have to manage. So that totally abstracts the software from the hardware. So a short word about some technical aspects. From the vendor perspective and also from the user perspective. So as a vendor, you need to make your OTT software compatible with containers and Docker. So that is, you need to redesign it in a way that does not interfere with the platform. So if your software interferes with the file system, network settings, you have to change it in a way so that it does not interfere anymore. you also have to reconsider your deployment and licensing mechanisms. That is with containers. There are existing systems, existing deployment system and licensing system that deploy containers on different hardware pieces. So you have to use that and get rid of your existing deployment system. Also, you have to ensure that performance is preserved. And for instance, you have to pay special attention when it comes to GPU-based video encoding. You have to make sure that GPU acceleration is preserved within a container. So those are vendor tasks. And on users, on the user side, is there any reason to not use containers? So there is nothing bad about containerization, generally speaking. Docker specifically is more a question of implementation. Our advice would be, if you don't have the Docker expertise, don't try to do it yourself. You have to leave it to your encoder or infrastructure vendor, and don't mess with it. As Docker is more a technology framework, you have to leave it to the person using Docker to build the complete service. I would like to say one word about microservices. So this is yet another buzzword, yet another paradigm. So what is a microservice? There is a definition on the web that is good, that one. A runtime which offers a single function, so this is a self-contained function. And to be considered as a microservice, it has to be elastic, resilient, so resistant to failures, composable with other microservices, minimal, doing one function, and complete. And microservices are composed to build an app. So this is another way to decompose an application, a software, into different components. A finer way. A good candidate for microservices is, for instance, a just-in-time packager for OTT TV, because you can see a just-in-time packager as composed of an ingest microservice, the input, the storage to store that input, and then the packaging microservice itself. So if you build that just-in-time packager as a set of 3 microservices, you can scale them individually, depending on whether the input grows, the storage needs grow, or the viewing needs grow. So this brings elasticity. So what is the relation with containers and Docker? Actually, Docker is a good place to run microservices. There is yet another paradigm. This is called serverless architecture. So a small note about that. Going one step further, you can still decompose microservices into simple functions, and then you just spread functions on different servers. So this model is called function as a service. And that exists, actually. This is already deployed, for instance, at Azure. You can deploy functions on the Azure cloud. So going to the conclusion, what we are assisting to is a transition to containers. So we've been using hardware custom encoders in the past, and we've seen that shift happening. It has happened already, so now we are in this model, software OTT TV implementation. Software means you buy regular software, you buy regular hardware servers, and you put specific software on it. And now we see the shift to containerized OTT TV implementation, where you don't care anymore about which hardware server does what. You just deploy services as containers on an infrastructure. So you can deploy an elastic number of OTT TV encoders and packagers, for instance, mixed with other functions you don't have to care about. As key takeaways, to wrap up, so containerization is not new. This is new to us. The purpose is the same as for virtualization. That is to isolate the software from the hardware. You can run different functions in different containers to create a global system. Unlike virtualization, it preserves performance. So that is a very key point. And why we think this is an ideal paradigm to be used for OTT TV. This is all functions can be implemented in software. In OTT TV, the technical landscape is changing so rapidly that you have to change the versions of the different components quite in an easy way. You still need a maximum performance. You need to grow and reduce the services as the demand grows and reduces. So you need elasticity. And you need to decorrelate hardware life cycles from software life cycles. So that is why that blue text is why we think containers are related to OTT TV. And Docker is just one implementation of containers. A word about ourselves. So we are called KeyPixel. We do video encoders and packagers for OTT TV. And we release Docker-compatible OTT TV encoders and packagers since 2017. And from now on, we are part of Anivia. And KeyPixel becomes Anivia, and we can offer now the complete OTT TV processing chain, encoding, packaging, CDN, and Cloud DVR. Thank you. So if you have any questions, I will be available here.